Hi guys, this is the lesson from Tuesday, October 17th, pre-algebra. This is going to be kind of a quick lesson today, and hopefully you'll remember it from last year. It's lesson 6-5, solving proportions. So we're going to start by defining what a proportion is, and it's an equation that states two ratios or fractions are equal. And the way we solve proportions is by cross multiplying. Okay, so let me show you what that's going to look like, and hopefully you'll remember this from last year. So when you have two fractions set equal to each other, that's a proportion, and that's your clue that you can solve them by cross multiplying. So if you take the way that we draw this, and 36 times 9 forms one side of your equation, and then we cross multiply the other way, c times 15, and that forms the other side of our equation. Then all we need to do is simplify. 36 times 9 is going to be 324, and we're just going to switch this around because you know when you write a term like that you always put your number first. So now you can see this is just a very easy one-step equation. We're going to divide both sides by 15, and our answer is going to be C is equal to 21.6. Okay? Very easy to check a proportion. Just like we do with our regular equations, we're going to plug in our value for C in the original equation. So 21.6 divided by 36 is hopefully equal to 9 divided by 15. So we use our cross products here to check to see if we have done this correctly. And again, 36 times 9 equals 324. And if I check it going this way, 21.6 times 15 is also 324. So I know that my answer is correct. Okay, we look at one more example. Again, we're going to draw our little cross multiplication oval. So I'm going to have V times 4.8 is equal to 16 times 1.5. If I simplify that, I have 4.8V is equal to 24. And then again, just one step to solve. Divide both sides by 4.8. And I get 5. To check my answer, I'm going to plug in that value of 5, where V is in the original equation. Then I'm going to use my cross products to see if I have done this correctly. So 5 times 4.8 is equal to 24. And 16 times 1.5 is also equal to 24. So I know I did that right. Not hard at all if you just remember how to set your equation up from your cross multiplication. Now let's take it a step further and let's talk about how we're going to solve a proportion that has an expression embedded in it. So on your notes, I want you to put yourself a little note here. Remember, parentheses around the expression. This is going to keep you straight when you go to multiply in your equation. So anytime you see an expression in one of the ratios, or sometimes it'll be in both ratios, I want you to go ahead and put your parentheses around that expression. Because now when I cross multiply my 7, I'm going to be reminded that that 7 needs to be distributed to every term in that parentheses. Then when I cross multiply the other way, 9 times 14. There's my equation. So now when I distribute my 7, I get 7b equals 77, plus 77 equals 126. If I subtract 77 from both sides, I get 7b equals 49. And when I divide both sides by 7, I get b is equal to 7. Now you can check this just as easily by plugging in the 7 for b in the equation, and it should work. All right, let's look at one more with the expression. I'm going to start by putting my x plus 5 in parentheses. When I multiply my 4 times the parentheses, that will remind me to distribute. And then the other side is 16 times 5. So when I distribute, this is going to be 4x plus 20 equals 80. Just a two-step equation now. Subtract 20 on both sides. And 4x equals 60. I'm going to come up here because I wrote too big for my space. Divide by 4 and I get x is equal to 15. So it's the same process as we were doing up top with just the single numerator and denominator. Just remember to always put your expression in the parentheses. All right, let's look at one last example. This is when you've got a story problem and you want to use a proportion to solve it. The most important thing about this is keeping your two numerators the same. You notice they have crackers on the top, calories on the bottom, and your two denominators the same across both ratios. So let's read the problem. A serving of 4 crackers contains 70 calories. How many calories are in 7 crackers? So I'm going to start with my initial ratio that was given here. 4 crackers equals 70 calories. And then it says how many calories are in 7 crackers. So my 7 goes on top and my variable goes with what I don't know, which is how many calories. So now I'm going to cross multiply, and I've got 70 times 7 equals 4 times x. So this is 490 equals 4x. And when I divide both sides by 4, I get that x is equal to 122.5 calories. So that's how many calories would be in 7 crackers. So even in a story problem, even in a real world problem, we can use proportions to solve for an unknown amount. Now let's look at B. B doesn't have it labeled out for us, so we're going to have to label it ourselves. I do want to change this word score to how many goals, just so it goes better with what the problem is saying. So if 6 goals are scored in 14 games, how many goals can be expected in 9 games? So I'm going to set this up to where I have goals on the top in the numerator and games on the bottom in the denominator. This labeling is just going to keep me straight as I write my ratios in the proportion. So it says 6 goals are scored in 14 games. So remember, goals are on top, games are on the bottom. There's my first ratio. Now I'm looking for how many goals, so that's going to be my variable, can be expected in 9 games. So there's my proportion. Goals are across the numerator, games across the denominator. Now I'm ready to solve. So if I cross multiply here, I get 14x for the first side and 6 times 9 for the second side. When I work this out and solve for x, I get x is equal to, and the way this comes out, guys, you may think you've done something wrong, but you haven't. Look at the calculator here. 54 divided by 14 doesn't come out to a whole number. It's 3.857 and so on. So I'm going to round that to 3.9. Now, remember what my problem is talking about. It's talking about how many goals. Now, can you make 3.9 goals? I don't think so. So the way you would answer this would be just what you would say if someone asked you. You would say about 4 goals. Okay? So you might say between 3 and 4, but it's much closer to 4, isn't it? So I think about 4 goals would be an accurate description of how many goals we could expect in 9 games. It's okay to estimate if your answer doesn't come out, evenly. Just make sure you give the most reasonable answer. I wouldn't say 3 because it's much, much closer to 4, isn't it? 3.9. So about 4 goals in 9 games would be my guess after looking at the 6 goals in the 14 games.